will not run. Second, even if it actually runs, do you need to rely on dynamic routing protocols to pass 800,000 routes to each other? This is too exaggerated. So we have a simple way. Since I now want to access any business on the public internet, all walk operators, then I will write a route now. This route represents all routes. That is, represents all addresses on the public network. Even all addresses in the world that conform to the IPv4 address configuration format. Write all. No matter where the data goes in the future. Take this device for the next hop. For example, this is an interface for interconnection between operators and devices. You will also assign addresses in the future. As long as you run services with fixed bandwidth, there will be a fixed address to connect with you. There is a static. We'll point to the operator on this device. As for how it got back, don't worry. Now for business. There is a route for the egress device, called the default route. Represent any piece of data in the future. Can match these 4 zeros represent unknown. Represents the least precise. Because its mask is 0. The longest mask match means it is more accurate. The longer the mask, the more accurate. Its mask is 0. Then it must be the least accurate. Some students may think that 800,000 routes are not too many for routers. Although it is a network device, the hardware used must be more advanced than PC. But we collectively call it a piece of hardware. Its computing power is also limited. If between devices, even if the data is sent out, query locally. How can more than 800,000 routes reach this device? Words learned through dynamic routing. Does running a protocol interact with each other so much? Then the overall bandwidth does not need to do other things. Just interact with the routing table. Business data cannot be forwarded at all. Suppose now there is a route 123.1.2.3. For example, next hop right is null. If there is a data coming now, can it be matched? Originally, if there is no this route to come here, just drop the packet. A data came. Device 1 helps it forward. Check the routing table and found no. This data is discarded, because the device can't help it forward. Now a route comes in on this device. Is the default route. Now if we match. Can it match? OK. Is allowed. For corporate exports here. Write a default point to the operator. Go to any business on the public network in the future. As long as the data reaches the gateway, it receives this data to help forward. They all go to the default operator. Same. Send this 123.1.2.3. It is possible to match. Only here because I didn't draw another line. Write next hop. I can only write a none to it. This thing you will learn in the future NP stage. I now ask you another question. Now comes a route 192.168.1.3. If send now, who will this traffic be sent to? OK. Will be sent to device 3. Because the following does not cover this address. So will 1.3 match this default route? Look at the data now. It also matches 4 zeros. It does not limit each bit. It seems different from others. Will not match the default route. The concept of default routing is, if there is now a route, at this point its destination and mask are both 0. In this situation, it represents a default route, also known as default route. So if it's a route like this, it can match all IP addresses in the whole network. But why doesn't it match what we just said? For the default route, since its mask is 0, It is a route with the worst matching order. Only when there is no local route to match will match the default route. Now comes a data check locally first. When it is determined that there is no precise route in the routing table, we'll match it to the default route. But unfortunately, there is a route here. Can help with precise forwarding. Then this default route will not be considered. Only as we just said, such a network segment sent over will consider the default route, because there is no detailed route locally to reach it. So the default route will be considered. Here are some relations between them. The above is about the addition and lookup of routing tables. We make a summary. For routing, if you choose to add routing table now, multiple routes now want to appear in the routing table. Then to make a comparison, to confirm the final route can appear in the routing table. This is called the principle of addition, followed by table lookup. If the current data arrived at a router, the function of the router is to help forward data. There are now multiple lines can go to the destination network. Then at this time, the local will be based on the routing table that has been generated. Select the one with the longest mask and send it. If now can't match any exact route, then if there is a default route locally, just match the default route and send it out. For example, now there is a default next hop. Point to this device. Just give it the traffic. There is a route to 1.1.1.1. Put the traffic to the middle, instead of going down. Here are some of the principles we talked about. Finally, let's look at the lookup table. Longest mask match. For example, I can now write 4 static routes. There are 4 S. Stands for static. Can point them to the same next pick. In theory, as long as the principle of addition table is met, it can be added. It doesn't matter if the next hop is the same, as long as the mask is inconsistent. Different purpose network. Different network segment. So now no matter the next hop is inconsistent. Add all. The routing table we are talking about now, it is reference to the destination network. As long as the following mask is inconsistent. Different destination network. Go to the only destination network. There will be a unique route. It will be processed by adding table principle. In addition, what is the difference between the default route and whether it is null? This may be misleading everyone. Logically speaking, we can add another line here. Add a device here. Let's say it's 4.1.1.2. 30-bit mask. It is also in the same network segment as it. This will write the next hop to here. Just because I didn't draw this device, I can't write a next hop. So I can only write a simplest way. The next hop can be represented by null. It's like I dropped it into a black hole. Black hole routing. But the NA stage will not learn this. The default route also points to the next hop. If the future comes a data arrives here. These 3 routes do not match. Data go here. Match the words. It is equivalent to such a route. Next hop is here. Then the null I just wrote is also the next hop. Only, the representative is not to send out this route. Instead,